Deep beneath the Earth's surface, in layers of rock and soil that date back millions of years, scientists have recently discovered something that challenges everything we thought we knew about the planet's history. Microscopic spheres made from rare metals like iridium, platinum, and gold, scattered across the globe, have been found in patterns that mirror the kinds of remnants left by modern nuclear testing. These microscopic spheres appear to have been formed through high-temperature processes that we've long associated only with nuclear explosions. But here's the catch. These spheres predate human civilization by millions of years, leading to a startling revelation. Could there have been advanced civilizations before us, civilizations so advanced that their technology was on par with or even exceeded our own? These discoveries, made by a team of geologists examining ancient layers of sediment, point to the possibility that Earth once hosted civilizations capable of advanced technologies we cannot even imagine today. The most intriguing part of this discovery is the timing. These microscopic spheres are embedded in rock layers that are more than 65 million years old, long before humans appeared on Earth. The idea that advanced technology could have existed so long ago defies everything we have been taught. But could it be possible? Could the Earth have seen civilizations rise and fall long before we emerged as the dominant species? For many years, the prevailing assumption was that humanity was the first to harness the power of atoms, to develop technologies that would change the course of our planet's future. We believed we were the first to burn fossil fuels, to manipulate the Earth's atmosphere, and to shape our environment on such a vast scale. But this discovery casts doubt on that assumption. These rare metals, often used in nuclear technologies, are scattered in such a way that it strongly suggests a pattern, not just random occurrences of these metals in the Earth's crust, but an actual signature of high-temperature processes. If these microscopic spheres were truly left behind by ancient nuclear activity, it would change the entire narrative of human history. The first step in understanding these findings is to consider the very nature of these microscopic spheres. The presence of metals like iridium is particularly important because they are incredibly rare on Earth. Iridium, for example, is mostly found in asteroids or in the remnants of meteorite impacts. The discovery of iridium in the geological record has been tied to the asteroid that struck the Earth 65 million years ago, contributing to the mass extinction of the dinosaurs. However, these new discoveries of microscopic iridium spheres are not tied to any impact event. They are scattered in rock layers all over the world, in patterns that cannot be easily explained by natural processes alone. What makes these spheres so intriguing is not just their composition, but their formation. Modern nuclear testing produces similar tiny metal spheres, formed from the intense heat generated during nuclear reactions. These spheres are the result of nuclear explosions that can reach temperatures of thousands of degrees Celsius, temperatures that are far beyond what typical volcanic or meteorite impacts can produce. The fact that these metal spheres, formed under conditions reminiscent of nuclear explosions, were found deep within Earth's geological record raises a fascinating question. If nuclear explosions occurred millions of years ago, could they have been part of an ancient technological process that we have yet to fully comprehend? The evidence begins to support a chilling idea. Earth may have once been home to advanced civilizations that had mastered technologies we're only now beginning to understand. These civilizations may have been capable of splitting atoms and manipulating the Earth's chemistry, much like we do today. The idea that these ancient societies could have existed and then vanished without leaving a trace has profound implications for our understanding of history. Could it be that our species is not the first to achieve such feats? And if so, what happened to these previous civilizations? Were they wiped out by a catastrophic event, or did they simply evolve into something else, leaving only these faint traces behind? In trying to make sense of these findings, scientists began to consider the scale of deep time, the vast stretches of geological history that span millions and even billions of years. If human civilization were to vanish tomorrow, future geologists would likely struggle to find evidence of our existence, buried beneath layers of sediment and rock. Even with all our advancements, our industrial activities may one day be lost to time, barely discernible to those who might come after us. This raises an even more profound question. If human civilization, with all its technology, can vanish without a trace, what about civilizations that existed long before us? Could they have left behind similar, albeit more subtle, traces that we simply haven't recognized yet. The possibility that Earth hosted advanced civilizations before humanity has been a topic of speculation for decades. Some researchers have even proposed theories about what such civilizations might have looked like. Could they have been more technologically advanced than we are? Could they have harnessed the power of nuclear energy or even more advanced technologies, and yet disappeared from the historical record? The discovery of these microscopic spheres provides tantalizing evidence that supports such theories. However, as exciting as these findings are, they also present a number of challenges. The biggest challenge is that the traces these ancient civilizations left behind are often too subtle to detect with our current understanding of geology and archaeology. In the years since these spheres were discovered, scientists have debated how to interpret the findings. While some argue that they are simply the result of natural processes, others contend that they are clear signs of ancient industrial activity. One of the biggest hurdles in studying ancient civilizations that may have existed long before us is that our understanding of what constitutes evidence of technology is still limited. We know what modern industrial activity looks like because we are living through it right now. But what if previous civilizations used entirely different materials or energy sources that we have yet to discover? What if they left behind traces that are completely foreign to our current understanding of technology? To answer these questions, scientists have turned to other clues in the geological record. One of the most compelling pieces of evidence comes from the study of mass extinctions. Throughout Earth's history, there have been several major extinction events where large portions of life on Earth were wiped out in a relatively short period. These extinctions have often been linked to dramatic changes in the environment, such as asteroid impacts, volcanic eruptions, or climate shifts. But what if these events were not entirely natural? What if some of these mass extinctions were the result of technological activity from previous civilizations, their industrial activities causing massive environmental upheaval? If such civilizations did exist, they may have altered Earth's environment in ways that we have yet to fully comprehend. We know that human industrial activity has changed the planet's atmosphere, releasing carbon dioxide and other greenhouse gases into the air. These gases have caused global temperatures to rise, contributing to climate change. What if similar changes occurred in the distant past, caused by technological civilizations long gone? Could their activities have left behind chemical traces in the Earth's atmosphere, traces that we might still be able to detect today? Some scientists believe that the patterns of mass extinctions and rapid environmental change found in the geological record could be the result of such ancient industrial activity. As we continue to study these microscopic spheres and the other evidence buried deep within the Earth's rock layers, we are forced to confront some difficult questions. How much of Earth's history have we truly understood? What if we are only scratching the surface of what is possible in terms of human and planetary development? Could it be that advanced civilizations, far older than humanity, once called Earth home? And if so, what can we learn from their rise and fall? The discovery of these microscopic spheres is just the beginning of a much larger mystery. As we continue to explore the ancient geological record, we may find more evidence that points to a time when Earth was home to civilizations that were both technologically advanced and tragically short-lived. And perhaps, just perhaps, we will uncover the keys to understanding our own future. Deep beneath the surface of Earth, we are uncovering traces of life from billions of years ago. But there's one moment in the planet's history that remains utterly baffling. It's a moment when life on Earth seemed to explode into a vast array of complex organisms. This event, known as the Cambrian explosion, occurred around 540 million years ago, and it left behind one of the most perplexing mysteries in the fossil record. Life on Earth, which had been primarily simple, single-celled organisms for billions of years, suddenly evolved into a vast array of complex, multicellular creatures. But why did this sudden and dramatic increase in biological complexity happen? And what caused it to occur virtually overnight in geological terms? The Cambrian explosion is a term used to describe an unprecedented burst of life on Earth that took place during the Cambrian period of the Paleozoic era. This period, which lasted from about 541 to 485 million years ago, is often seen as the birth of modern animal life. But what makes the Cambrian explosion so mysterious is how quickly it occurred. Before this event, life was largely microscopic and simple, with only a few types of organisms existing on the planet. After the explosion, Earth's oceans were teeming with creatures possessing complex body structures, eyes, shells, and other features that were previously unheard of. Imagine this: for over 3 billion years, life on Earth was dominated by simple organisms, such as bacteria and algae. Then, in a geologically brief period of time, roughly 20 million years, suddenly nearly every major group of animals appeared. It's as if someone flipped a switch and complex life forms began to emerge everywhere, almost out of nowhere. The fossil record, when studied closely, shows that this wasn't a gradual process at all, but rather an abrupt and dramatic event that left a clear imprint in the geological layers. But how could such a complex shift in biological diversity happen so quickly? To answer this question, scientists have proposed several theories, but none of them are fully conclusive. One of the most commonly suggested explanations is the idea that the Earth's environment underwent a dramatic change that allowed for the sudden burst of life. For example, the increase in oxygen levels in the oceans could have provided the necessary conditions for more complex life forms to develop. Before the Cambrian explosion, oxygen levels in the Earth's atmosphere and oceans were relatively low, which meant that only simple anaerobic organisms could survive. But as oxygen levels began to rise, it may have allowed more complex organisms to evolve, utilizing oxygen in their metabolic processes. Another theory suggests that the Cambrian explosion was triggered by changes in the Earth's climate. Perhaps the planet experienced a period of warming or a shift in the chemical composition of the oceans that made it more conducive to the development of complex life. Such environmental changes would have created new ecological niches, allowing for rapid evolutionary diversification. The sudden availability of new resources could have allowed different species to evolve quickly and fill those niches, leading to the emergence of new forms of life. However, this explanation still doesn't fully account for the speed and scale of the Cambrian explosion. While it's true that environmental changes can drive evolutionary changes, what's most puzzling about the Cambrian explosion is that the appearance of new life forms seems to have happened much more quickly than one would expect given the timescales of evolutionary biology. Most of the species that appeared during this period were fully formed, highly complex organisms with specialized body structures. The fossil record shows no intermediate forms, no gradual transitions between simple and complex organisms, which suggests that these creatures appeared almost all at once, in a blink of an eye in geological terms. One of the most striking aspects of the Cambrian explosion is the sheer diversity of life that emerged during this period. Species with hard exoskeletons, segmented bodies, and complex eyes suddenly appeared, many of them looking remarkably similar to modern animals. In fact, many of the basic body plans for modern animals, such as arthropods, mollusks, and vertebrates, can be traced back to the Cambrian period. These creatures, many of which were small and marine-based, established the foundation for much of the animal life that would follow. But the speed with which these creatures emerged and the complexity of their biological systems continues to baffle scientists. One of the most famous fossil sites from this period is the Burgess Shale, located in the Canadian Rockies. This site contains an astonishing variety of fossils from the Cambrian period, and it provides one of the most complete snapshots of early animal life on Earth. The fossils found here are incredibly well preserved, offering a glimpse into the biodiversity that existed during the Cambrian explosion. The creatures that inhabited this ancient seafloor were strange and otherworldly, with body structures and features that were unlike anything seen before in Earth's history. Some of these creatures, such as the famous anomalocaridids, had elongated bodies with compound eyes, and their specialized appendages may have been used for capturing prey. Others, like the trilobites, had complex exoskeletons that would go on to influence the development of arthropods for millions of years. What makes the Burgess Shale and other Cambrian fossil sites so intriguing is that they reveal a world full of experimentation in biological design. During the Cambrian explosion, nature seemed to be trying out many different ways of being, different body structures, feeding strategies, and methods of locomotion. Some of these experiments, such as the early arthropods and the strange, extinct creatures like hallucigenia, would not survive the course of evolutionary history. Yet others would become the building blocks of modern life. The Cambrian explosion, it seems, was a time of immense evolutionary creativity, as species rapidly diversified and adapted to new environments and challenges. But the mystery of the Cambrian explosion goes beyond just the sudden appearance of new life forms. It's also about the disappearance of many of these early species. While some of the creatures that emerged during the Cambrian period would go on to thrive and evolve into the animals we know today, many others vanished without a trace. Scientists believe that the Cambrian explosion may have been followed by several extinction events, which wiped out many of the early creatures. These extinctions, combined with the rapid diversification that preceded them, created a dynamic and ever-changing world for life on Earth. Despite decades of research, the Cambrian explosion remains one of the most profound and unresolved questions in the field of evolutionary biology. Why did life on Earth evolve so quickly? Was it due to environmental factors, or was there something more at play? Did the Earth's changing climate, rising oxygen levels, and new ecosystems spark the rapid diversification of life, or was it something else entirely? The answers to these questions may lie hidden in the geological layers, waiting for future generations of scientists to uncover. What we do know for certain is that the Cambrian explosion represents one of the most fascinating and enigmatic periods in Earth's history, a time when life seemed to burst forth in all its complexity and diversity, setting the stage for the world we know today. But there's another layer to this mystery. Some scientists have proposed that the Cambrian explosion might not be the only instance of such rapid evolutionary leaps. Perhaps life on Earth has experienced similar bursts of creativity and innovation in the past, but these moments were lost to time. If this is true, then the Cambrian explosion might not have been a singular event, but part of a much larger pattern of rapid evolutionary changes that we have yet to fully understand. Could it be that the Cambrian explosion was only the latest in a series of such events, each triggered by some unknown factor that caused life to evolve in unexpected and dramatic ways? In the end, the Cambrian explosion is more than just a fascinating chapter in the history of life on Earth. It's a reminder that there is still so much we don't know about our planet's past. The complexity of life, the sudden appearance of new species, and the mysteries of evolution all remain tantalizing puzzles that continue to challenge us. But it's also a testament to the power of life itself, a force that, despite the challenges and uncertainties of the ages, continues to adapt, survive, and evolve in ways we can only begin to comprehend. The history of life on Earth is a tale written in the stone of ancient rocks, etched in the bones and remnants of creatures that once walked the Earth. But that story is far from complete. The fossil record, which is our primary window into the past, is riddled with gaps, enormous gaps, that leave entire chapters of life's history unwritten. Scientists have long debated why the fossil record is so fragmented and what those missing pieces mean for our understanding of evolution. The fossil record should tell a complete story of how life evolved over millions of years. Yet instead, it's like a book with missing pages, leaving us with an incomplete picture of how life unfolded on Earth. But the question remains, why? What happened to those missing fossils? And why do so many of them seem to have vanished without a trace? The fossil record consists of preserved remains, traces, or imprints of organisms that lived long ago, often millions of years ago. These remains, found in sedimentary rock layers, provide us with a detailed history of the organisms that once lived on Earth. Fossils have been used to study the evolution of life, the appearance of new species, and the extinction of others. But one of the biggest mysteries in the study of fossils is the sheer number of missing fossils. The gaps in the fossil record are so large that it can sometimes seem as though entire species, or even entire groups of organisms, suddenly appear or disappear from history without any clear explanation. One of the most famous gaps in the fossil record is the absence of transitional forms, the creatures that bridge the gap between different groups of animals. Take, for example, the evolution of fish into amphibians. We know that amphibians evolved from fish, but finding fossils of creatures that show the transition between these two groups has proven to be incredibly difficult. While we have some fossils of early amphibians, there are very few fossils of fish-like creatures with features that would allow them to live both in water and on land. This missing link has puzzled scientists for centuries, and despite numerous discoveries, the gap remains only partially filled. The lack of transitional fossils is not limited to the fish-to-amphibian transition. In fact, every major evolutionary step seems to be marked by significant gaps in the fossil record. The evolution of reptiles from amphibians, the rise of mammals from reptiles, and the emergence of humans from primates. Each of these transitions has gaps that leave us with little to no fossil evidence of the intermediary species. So, why are there so many gaps? Is it because the creatures in question never existed? Or is it simply that the conditions for fossilization were never right? One explanation for the missing fossils is that fossilization is a rare event. Fossils are created when organisms are buried quickly in sediment, which preserves their bones or shells. However, this process requires very specific conditions, such as the right kind of sediment, the right environmental factors, and the right amount of time. The vast majority of organisms that lived on Earth simply did not become fossilized. Most animals and plants decompose before they have a chance to be preserved, leaving no trace behind. As a result, the fossil record is heavily biased toward certain types of organisms, such as those with hard shells or bones, and those that lived in areas conducive to fossilization, such as shallow seas or riverbeds. Soft-bodied organisms, such as jellyfish, worms, and many other creatures, rarely fossilize, which means that vast swathes of life's history are simply missing from the record. But there's more to the mystery of the fossil record than just the rarity of fossilization. Even in cases where fossils have been preserved, many of them are buried so deep in the Earth's crust or are otherwise difficult to find that they remain undiscovered. Geological forces, such as tectonic activity, can also destroy fossils, particularly those that were once near the Earth's surface but have been pushed deep underground over millions of years. The shifting of continents, the movement of glaciers, and the erosion of landscapes can all contribute to the destruction or displacement of fossils, leaving important pieces of the puzzle hidden from view. There's another factor at play here that complicates the story of life on Earth. The Earth itself is a dynamic, ever-changing planet. Over the course of its 4.5 billion-year history, the planet has undergone numerous catastrophic events. Mass extinctions, volcanic eruptions, and asteroid impacts that have wiped out vast numbers of species and altered the course of evolution. Each of these events has left its mark on the fossil record, but it has also contributed to the loss of countless organisms. When entire ecosystems are wiped out in an extinction event, many species are lost forever, leaving no trace behind. While we can sometimes identify the cause of these extinctions, such as the asteroid impact that killed the dinosaurs, many mass extinction events have left no obvious clues as to why species vanished. The fossil record shows us the aftermath of these events, but it often provides little insight into how life bounced back or what new species emerged in the wake of the destruction. One of the most famous examples of a mass extinction is the event that occurred around 66 million years ago, when the dinosaurs were wiped out. This event, which is widely believed to have been caused by a massive asteroid impact, created a sudden and dramatic shift in the Earth's ecosystems. The fossil record tells us that, in the aftermath of the extinction, new groups of animals, particularly mammals, began to diversify and fill the ecological niches left by the dinosaurs. But the fossil record of this transition is still incomplete. While we know that mammals emerged during this time, the exact process of how they took over the Earth's ecosystems remains a mystery. The gaps in the fossil record are not just limited to the time before humans. Even in our own evolutionary history, there are major gaps that leave us with only partial understanding of how Homo sapiens evolved. The fossil record shows that early humans and their ancestors were a diverse group, with many different species of hominids living at the same time. Some of these species are closely related to modern humans, while others are more distantly related. But there are significant gaps in our understanding of how these species are connected. For example, while we know that Homo sapiens evolved from earlier hominids, the exact path of that evolution is still unclear. The missing fossils, the transitional forms that show the gradual changes from one species to another, are hard to find, leaving us with many unanswered questions about how and why our ancestors evolved in the way that they did. Despite these challenges, the fossil record remains one of the most important tools we have for understanding the history of life on Earth. Even though it's incomplete, it still offers us incredible insights into how life has evolved, how ecosystems have changed, and how mass extinctions have shaped the planet. The fossils we do have provide valuable clues about the organisms that lived in ancient environments, from the small, simple creatures of the Cambrian period to the giant dinosaurs that once roamed the Earth. Through these fossils, we can reconstruct ancient ecosystems and learn about the behaviors, diets, and physical characteristics of long-extinct species. Moreover, modern techniques in paleontology, such as genetic analysis and computer modeling, have allowed scientists to fill in some of the gaps in the fossil record. By studying the DNA of living species and comparing it with ancient fossils, researchers can better understand how different species are related and how they evolved over time. New technologies, like 3D scanning and advanced imaging techniques, have also allowed paleontologists to study fossils in more detail than ever before, revealing new information about the life forms that once inhabited the Earth. While the fossil record will never be complete, each new discovery adds another piece to the puzzle. With each fossil, scientists gain a better understanding of how life on Earth evolved, and the gaps in the fossil record become a little smaller. But the missing pieces of life's story will always remain a mystery, tantalizing scientists with the unknown. As we continue to explore Earth's ancient past, we can only hope that more fossils will be uncovered, bringing us closer to answering the questions that have puzzled scientists for centuries. In the end, the fossil record, with all its gaps, remains one of our most powerful tools for understanding the history of life on Earth. It tells a story that is still being written, and every discovery brings us one step closer to uncovering the secrets of the past. Roughly 540 million years ago, Earth witnessed one of the most dramatic biological events in its history, the Cambrian explosion. Within a relatively short period of time, life on Earth exploded in complexity. Simple, microscopic organisms gave way to a wide variety of creatures with eyes, hard shells, sophisticated body plans, and the ability to move, hunt, and reproduce in new ways. The Cambrian explosion represents one of the most important chapters in the history of life, but it also raises one of the most puzzling questions in evolutionary biology. Why did life suddenly become so complex? And why did this surge of diversity occur so rapidly without clear predecessors? Before the Cambrian explosion, life on Earth was dominated by simple, single-celled organisms and microscopic, multi-celled creatures. While the fossil record shows evidence of life on Earth for billions of years, this early life was simple and relatively homogeneous. Organisms were mostly soft-bodied, and many lacked complex features like hard shells or complex organs. But during the Cambrian period, something changed. Within just a few million years, life forms began to diversify at an astonishing rate, giving rise to nearly all of the major animal groups that exist today. One of the most remarkable aspects of the Cambrian explosion is the sudden appearance of complex body plans. In the fossil record, we see the emergence of creatures with distinct, specialized features, such as exoskeletons, eyes, legs, and specialized feeding organs, features that would later evolve into the body plans of modern animals. For example, creatures like Hallucigenia, Anomalocaris, and trilobites appeared during this time, all exhibiting unique body structures that were previously unseen. These creatures were more complex than anything that had existed before them, and their diversity was unlike anything seen in the Earth's earlier history. But perhaps even more puzzling than the rapid diversification of life is the fact that the fossil record shows little to no evidence of transitional forms that might explain how these complex creatures came to be. If life on Earth evolved gradually from simple to complex, as Darwin's theory of evolution by natural selection suggests, then why is there such a sudden and dramatic appearance of fully formed, complex organisms in the fossil record? What happened to the earlier forms of life that must have existed prior to the Cambrian period? Why are these early transitional species so rare or entirely absent? This question is known as the Cambrian explosion paradox. One possible explanation is that the conditions for fossilization were simply not right before the Cambrian period. Fossilization, as we know, is a rare and specific process that requires organisms to be rapidly buried in sediment. Before the Cambrian period, Earth's ecosystems may not have been conducive to preserving life forms in the same way that they were during the Cambrian explosion. Soft-bodied organisms, for instance, are less likely to fossilize, and before the Cambrian period, most life forms were soft-bodied. The sudden appearance of complex, Hard-bodied creatures with shells or exoskeletons might have simply made it easier for these creatures to fossilize, leaving a more complete record behind. Another theory is that the Cambrian explosion occurred due to environmental changes that triggered a rapid increase in biodiversity. During the late Precambrian period, Earth underwent significant geological, climatic, and atmospheric changes. One such change was the increase in oxygen levels in the oceans and atmosphere, which may have allowed more complex, energy-demanding life forms to evolve. The increase in oxygen would have provided organisms with the energy needed to grow larger and develop more complex body structures. Other factors, such as changes in ocean chemistry, sea levels, and the availability of nutrients, may have also contributed to the rapid burst of diversification. But the Cambrian explosion is not just a story about the sudden appearance of complex life forms. It's also a story about the sudden appearance of new ecosystems. During the Cambrian period, animals began to evolve new ways of interacting with their environment. Some creatures developed the ability to burrow into the ocean floor, while others evolved to swim through the water. This marked the beginning of complex ecological relationships, including predator-prey interactions and competition for resources that would continue to shape life on Earth for millions of years. What's more, the Cambrian explosion also gave rise to the development of many of the major animal groups that still exist today. The ancestors of modern arthropods, mollusks, chordates, and echinoderms all made their first appearance during this period. It was also during this time that the first true vertebrates, animals with backbones, emerged, setting the stage for the later evolution of all vertebrate animals, including humans. The Cambrian period, therefore, is often considered the birthplace of modern animal life. Despite the dramatic diversification that occurred during the Cambrian explosion, it didn't mark the end of life's evolutionary journey. Rather, it laid the groundwork for the evolution of the more complex life forms that would come after it. Life continued to evolve, and over the next several hundred million years, animals evolved new body plans, new behaviors, and new ecological roles. But the Cambrian explosion remains a defining moment in the history of life on Earth, a moment when life began to take the forms we are familiar with today. One of the most significant consequences of the Cambrian explosion was the rapid development of animal diversity. Before the Cambrian period, life was primarily composed of simple, microscopic organisms. But after the explosion, the fossil record shows a dramatic increase in the number of species, with a wide variety of body plans and ecological roles. In fact, many of the major animal groups that we see today, such as arthropods, mollusks, and vertebrates, trace their origins back to the Cambrian period. The diversification of life during this time set the stage for the complexity and variety of animal life we see on Earth today. In addition to the appearance of new animal forms, the Cambrian explosion also marked the emergence of complex ecosystems. Before this period, Earth's ecosystems were relatively simple, with few interactions between species. However, during the Cambrian period, animals began to interact in more complex ways, developing predator-prey relationships, competition for resources, and symbiotic partnerships. This marked the beginning of the intricate web of life that would continue to evolve and diversify over time. Despite its importance, the Cambrian explosion remains a subject of much debate among scientists. While there are several theories that attempt to explain the sudden burst of life, there is still much we do not know about this critical period in Earth's history. Some scientists argue that the increase in oxygen levels played a key role, while others point to changes in the Earth's environment or the development of new genetic mechanisms as possible explanations. What is clear, however, is that the Cambrian explosion was a pivotal moment in the history of life on Earth. It represents a time when life became more complex, more diverse, and more interconnected, setting the stage for the evolution of the world's modern ecosystems. The Cambrian explosion is not just a tale of evolution. It's a reminder of how life on Earth is constantly changing and adapting to new circumstances. It serves as a testament to the incredible creativity and resilience of life, and a reminder that we still have much to learn about the history of our planet. By studying this remarkable event, scientists can gain valuable insights into the processes that drive evolution, the ways in which life responds to environmental changes, and the complex relationships that shape ecosystems. While the Cambrian explosion remains one of the most profound events in the history of life on Earth, It is also a mystery that continues to challenge our understanding of evolution and the natural world. By studying the fossils of this period, we can uncover new clues about the origins of life, the development of complex ecosystems, and the ever-changing story of life on Earth. Mass extinctions have dramatically altered the course of life on Earth. These events, which have wiped out vast numbers of species, reshaped ecosystems and paved the way for new life forms to emerge. But despite their significance, mass extinctions are often misunderstood. They are frequently portrayed as sudden, catastrophic events triggered by external forces like asteroid impacts or volcanic eruptions. While these events are certainly part of the story, mass extinctions are much more complex. They represent a series of interconnected environmental, biological, and atmospheric changes that have played out over millions of years. Understanding these cataclysmic events helps us to better understand our planet's history, the fragile nature of life, and perhaps even how we might be able to avoid triggering an extinction event ourselves. The first of the 5 major mass extinctions in Earth's history occurred around 445 million years ago, in the Ordovician-Silurian period. During this time, approximately 85% of all marine species were wiped out, largely due to a sudden and dramatic drop in temperature. This glaciation event is thought to have been triggered by the formation of the supercontinent Gondwana over the South Pole, which led to an ice age. The cooling of the Earth caused sea levels to drop, cutting off shallow coastal habitats and reducing the amount of oxygen in the ocean. The Ordovician-Silurian extinction marks the beginning of Earth's recurring mass extinction events, each of which would dramatically alter life on the planet. The next major extinction event occurred around 252 million years ago, at the end of the Permian period. Known as the Permian-Triassic extinction, this was the largest mass extinction in Earth's history, wiping out nearly 96% of all marine species and 70% of terrestrial vertebrates. The causes of this event are still debated, but it is believed to have been triggered by a combination of factors, including massive volcanic eruptions in what is now Siberia. These eruptions released enormous amounts of carbon dioxide and other greenhouse gases into the atmosphere, leading to global warming, ocean acidification, and a lack of oxygen in the oceans. The aftermath of this extinction event led to the rise of new life forms, including the dinosaurs, which would dominate the Earth for the next 180 million years. Fast forward to around 66 million years ago, and we encounter another mass extinction event, the Cretaceous-Paleogene (KPG) extinction, which wiped out the dinosaurs and many other species. This extinction event is the most famous because it was likely triggered by an asteroid impact near the Yucatan Peninsula in what is now Mexico. The impact released an enormous amount of energy, causing massive wildfires, tsunamis, and throwing up so much dust and debris into the atmosphere that it blocked sunlight for months, if not years. This drastic change in climate led to the extinction of the dinosaurs and many other species, opening up ecological niches that allowed mammals to evolve and eventually dominate the planet. It is this event that paved the way for the rise of human beings and the ecosystems we know today. However, the story of mass extinctions is not just about asteroid impacts or volcanic eruptions. These events are often caused by complex, interwoven processes that involve the gradual buildup of environmental stresses, such as climate change, ocean acidification, and habitat loss. For instance, the most recent mass extinction event that occurred around 66 million years ago didn't happen overnight. It was a slow, gradual process that took millions of years to unfold. The climate was already changing before the asteroid impact, with the Earth entering a cooling period that caused stress to many species. In fact, some scientists argue that mass extinctions may not be as rare as we think. While the 5 major events are the most well-known, there may have been many smaller, less dramatic extinctions that have gone unnoticed. Over the course of Earth's history, environmental pressures such as volcanic activity, changes in sea levels, and even the evolution of new species have triggered shifts in ecosystems. These smaller events may not have caused the widespread extinction of species, but they may have set the stage for larger-scale extinctions down the road. In the modern world, the threat of another mass extinction looms large. While we are not facing an asteroid impact or massive volcanic eruptions, human activity has created its own set of pressures on the planet. Deforestation, overfishing, pollution, climate change, and the destruction of habitats are all contributing to a gradual loss of biodiversity. According to many scientists, we are currently living through what some have dubbed the sixth mass extinction. Unlike the previous 5, however, this one is caused not by natural forces, but by human activity. The evidence of this is everywhere. Species are disappearing at an unprecedented rate, ecosystems are breaking down, and the delicate balance of life on Earth is being disrupted. What's more concerning is that, unlike previous extinctions, we have the power to accelerate or slow down this process. For the first time in history, humanity has the ability to influence the fate of life on Earth. But the question is, will we? The future of biodiversity on Earth depends on how we respond to the current crisis. If we continue down the path of environmental destruction, we may find ourselves witnessing the collapse of entire ecosystems, the extinction of species, and the unraveling of the natural systems that support life. Alternatively, if we take decisive action to combat climate change, protect habitats, and restore ecosystems, we can help slow or even reverse the damage we have caused. One of the most significant consequences of mass extinctions is the way they reshape ecosystems. When a large number of species go extinct, new niches open up, allowing other species to evolve and fill those gaps. This is what happened after the extinction of the dinosaurs. Mammals, which had previously been small, nocturnal creatures, began to evolve into the dominant species on Earth. Over millions of years, mammals diversified into a wide range of forms, including primates, cetaceans, and, eventually, humans. This process of adaptive radiation, in which new species evolve to fill available ecological niches, has shaped the diversity of life on Earth. Mass extinctions also provide valuable lessons for us as we consider the current biodiversity crisis. They show us that life on Earth is resilient, but it is also fragile. While ecosystems can recover from catastrophic events, the process takes time, often millions of years. For example, after the Permian-Triassic extinction, it took Earth around 10 million years for biodiversity to fully recover. This means that if we allow ecosystems to collapse, the recovery process could take far longer than our lifetimes. If we want to avoid a similar fate, we must take immediate action to protect the biodiversity that remains. One of the most important lessons mass extinctions teach us is the interconnectedness of life on Earth. Every species, no matter how small or seemingly insignificant, plays a role in maintaining the health of ecosystems. The loss of one species can have ripple effects that affect many others. For example, the loss of a keystone predator can lead to an overpopulation of prey species, which in turn can damage vegetation and disrupt the food chain. The collapse of ecosystems due to the loss of biodiversity can have far-reaching consequences, affecting everything from the availability of food and water to the stability of the climate. In conclusion, mass extinctions are not just events of the past. They are a critical part of Earth's ongoing story. They are a reminder of the fragility of life and the importance of preserving biodiversity. While mass extinctions have reshaped the course of life on Earth in the past, we now have the ability to shape the future. The actions we take today will determine whether we continue the cycle of rise and fall or break the pattern and create a more sustainable, resilient world. The lessons of the past are clear. Life on Earth is incredibly diverse, but it is also incredibly fragile. It is up to us to ensure that we don't repeat the mistakes of the past, but instead build a future where life on Earth can thrive for generations to come. From the Great Pyramids of Giza to the ancient temples of Angkor Wat, the remnants of long-lost civilizations are scattered across the Earth. These impressive structures and artifacts tell the story of human ingenuity and achievement. But the most puzzling question that continues to linger is, how did these ancient civilizations manage to construct such monumental works with the limited tools and technology available to them? Were these achievements the result of an unknown scientific understanding that was lost to time? Or could it be that these ancient societies had access to advanced technologies far beyond what we believe they could have possessed? The idea that ancient civilizations may have had access to lost or mysterious technologies is not a new concept. For centuries, historians and archaeologists have debated the extent of the knowledge and capabilities of these ancient societies. Some of these theories argue that ancient civilizations were far more advanced than we give them credit for, possessing technologies that allowed them to accomplish feats we can barely understand even today. The alignment of the Great Pyramids with the stars, the precise stonework at Machu Picchu, and the transportation of massive stones used in constructing Stonehenge are just a few examples that continue to baffle scientists. These monuments and artifacts suggest that the ancient world was far more technologically advanced than we often assume. Consider the ancient Egyptians. The construction of the Great Pyramid at Giza, which stands as one of the 7 wonders of the ancient world, has long been a source of intrigue. The pyramid was built with over 2 million stone blocks, each weighing several tons. Modern engineering techniques would struggle to move such large stones with the precision and alignment found in the pyramid's construction. It's been estimated that the stones were moved over great distances, possibly from quarries hundreds of miles away. The precision with which the pyramid was built, including its alignment to the cardinal directions, raises questions. How did the Egyptians, with their primitive tools and methods, manage to accomplish such a feat? Some theorists believe that they used advanced methods of levitation, sound frequencies, or even lost knowledge of anti-gravity technology. While there's no definitive evidence to support these ideas, the sheer complexity of the task suggests that the ancient Egyptians might have had access to knowledge that is now lost to us. Another example comes from the ancient city of Baalbek in Lebanon, where enormous stones weighing up to 800 tons are still in place at the Temple of Jupiter. The precision with which these massive stones were cut and positioned is astonishing. No modern machinery can lift or move stones of such size, yet the ancient builders at Baalbek managed to do so with a level of accuracy that still baffles engineers today. The stones were cut with such precision that they fit together perfectly, with no mortar used to hold them in place. Some theories suggest that the builders of Baalbek had access to unknown technology, perhaps even advanced machinery or methods for manipulating matter at the atomic level. Could it be that the people of Baalbek had access to a type of lost technology that allowed them to move these massive stones with ease? The ancient ruins of Angkor Wat in Cambodia also present a similar mystery. The temple complex, which is the largest religious monument in the world, was built in the early 12th century. The scale of the structure and the intricate carvings suggest a level of precision that seems beyond the capabilities of the time. The Angkor civilization was highly advanced in terms of water management and agriculture, but the level of craftsmanship and the techniques used to build the temple complex continue to raise questions. Some researchers have suggested that the builders of Angkor Wat possessed knowledge of advanced engineering methods that have since been lost. The precision with which the temple stonework is fitted together, with no mortar between the blocks, is similar to the construction techniques seen at other ancient sites, such as those in Egypt and Peru. Could the ancient builders have been using a lost technology to construct these massive stone structures? The mystery of ancient technologies doesn't end with monumental architecture. Many ancient texts and artifacts also suggest that these civilizations had an understanding of the natural world that is far beyond what we would expect given their technological limitations. For example, the ancient Sumerians, who lived in Mesopotamia around 6,000 years ago, had a remarkable knowledge of astronomy. Their observations of the stars and planets were incredibly accurate, and they created detailed star charts that have been shown to be nearly as accurate as modern astronomical data. The Sumerians were also known for their advanced mathematics, using a sexagesimal, base 60 number system, which is still used today to measure time and angles. This knowledge of the stars and the mathematical precision with which they tracked celestial bodies suggests that the Sumerians had a sophisticated understanding of the universe that goes beyond what we would expect for their time. Similarly, the ancient Greeks were renowned for their achievements in mathematics, science, and engineering. The Antikythera mechanism, a device discovered in 1901 off the coast of the Greek island of Antikythera, is an example of the advanced technology used by the Greeks. The mechanism, which dates back to around 100 BCE, is an ancient analog computer that was used to predict astronomical positions and eclipses. The sophistication of the Antikythera mechanism has led some researchers to suggest that the ancient Greeks possessed knowledge of mechanical engineering that was not rediscovered until the 18th century. The complexity of the device, with its intricate gears and precision, indicates that the Greeks had mastered mechanical principles that we would consider advanced even today. In India, the ancient Vedic texts are full of descriptions of flying machines known as vimanas. These machines are described as having the ability to travel through the air and even into space. Some accounts describe vimanas as having the ability to move at incredible speeds and to perform maneuvers that would be impossible with modern aircraft. While these descriptions are often considered mythological, there are those who believe that they may contain hidden knowledge of ancient technologies that were lost or suppressed over time. Some even suggest that the vimanas could have been actual machines that used advanced forms of propulsion, possibly even anti-gravity or electromagnetic fields, to travel through the air. While there is no definitive proof that ancient civilizations had access to technologies that are lost to us today, the evidence of their achievements is undeniable. From the construction of massive monuments to the understanding of the stars, the ancient world demonstrates an incredible level of knowledge and ingenuity. The question is, what happened to this knowledge? Why did it disappear, and can we ever recover it? The most likely explanation is that much of this knowledge was lost over time due to the rise and fall of civilizations. As empires crumbled and cultures vanished, much of the technological and scientific knowledge of the time was lost. It is possible that the knowledge was preserved in texts, oral traditions, or even artifacts, but over time these records were destroyed, forgotten, or misunderstood. However, there is also the possibility that some of this knowledge was deliberately suppressed or hidden. Throughout history, there have been instances where knowledge, particularly knowledge related to advanced technologies, was controlled by the elites in power. These elites may have chosen to keep this knowledge from the general populace, either to maintain their control or to prevent the misuse of such powerful technologies. Another possible explanation is that the knowledge was simply too advanced for the time. Many ancient civilizations may have reached a point where their technology outpaced their ability to understand or maintain it. Like modern societies, ancient civilizations may have experienced periods of rapid technological advancement that led to unintended consequences. If such civilizations collapsed before they could fully understand or control their technology, much of that knowledge would have been lost. Some researchers believe that the key to uncovering this lost knowledge may lie in the discovery of new artifacts, ancient texts, or hidden ruins. Modern technology, such as ground-penetrating radar and satellite imaging, has already allowed archaeologists to uncover ancient cities, temples, and tombs that were once thought to be lost. As our technology improves, it is likely that we will uncover even more evidence of advanced ancient technologies that were previously hidden beneath the sands of time. In conclusion, the mystery of ancient civilizations and their lost technologies continues to captivate the imagination of scholars and enthusiasts alike. While there is no definitive proof that these civilizations possessed advanced technologies beyond our current understanding, the evidence suggests that they may have had access to knowledge and techniques that have since been lost or suppressed. As we continue to explore the remnants of these ancient societies, we may one day uncover the secrets of their achievements and learn from the wisdom of the past. The quest for this lost knowledge is not just about discovering the achievements of ancient civilizations. It is about understanding the potential of humanity itself. Could we one day rediscover the technologies of the past and use them to shape a better future? The answer to that question may lie buried in the ruins of the ancient world, waiting to be uncovered. Across history, ancient civilizations have left behind remarkable monuments, texts, and artifacts that have confounded scholars for centuries. From the pyramids of Egypt to the stone circles of Stonehenge, these structures continue to inspire awe, not just for their sheer size and beauty, but for their precision and craftsmanship. But what if the true significance of these ancient wonders lies not only in their architectural prowess, but in the knowledge that fueled their creation? Could the ancient world have had access to scientific principles and technologies that modern society is only just beginning to understand? Could these ancient civilizations have laid the groundwork for many of the scientific advancements that we now take for granted? In the modern age, we often assume that technological progress is a linear path, with each new discovery building upon the last. However, looking at the achievements of ancient civilizations, it's clear that they were capable of remarkable scientific feats, many of which have only recently been replicated or even fully understood by contemporary scientists. In fact, it's becoming increasingly clear that the knowledge of the ancients had a lasting impact on the development of modern science and technology. From the Egyptians' understanding of geometry to the Greeks' advances in mathematics and astronomy, the foundations for many of today's scientific breakthroughs were laid long ago. One of the most striking examples of ancient knowledge influencing modern science is the ancient Egyptians' mastery of geometry and engineering. The construction of the Great Pyramid of Giza, for instance, is still a subject of intense study and admiration. This architectural wonder, built over 4,500 years ago, was constructed with an incredible level of precision. The sides of the pyramid are aligned almost perfectly with the cardinal directions: north, south, east, and west, something that would have been extraordinarily difficult to achieve without advanced knowledge of astronomy and geometry. In fact, the Egyptians' understanding of geometry was so advanced that it would not be until the Greek mathematician Euclid came along centuries later that similar techniques were refined and developed into the formal geometry that we know today. The Egyptians also demonstrated an understanding of mathematical principles far beyond what was initially believed possible for their time. The precision with which they calculated the volume and area of shapes, and their application of these principles in the construction of the pyramids, suggests that they had an intuitive grasp of mathematics. Some researchers argue that the Egyptians were aware of the so-called Pythagorean theorem, a principle that was later formalized by the ancient Greek mathematician Pythagoras. Long before Pythagoras lived, the measurements of the Great Pyramid, when calculated using modern tools, demonstrate a close approximation to the values dictated by this theorem. In addition to their engineering feats, the Egyptians also made significant contributions to medicine. Many modern medical practices, such as the use of surgical instruments and the practice of embalming, can trace their roots back to ancient Egypt. The famous Edwin Smith papyrus, dating to around 1600 BCE, contains detailed medical knowledge on the diagnosis and treatment of various injuries, including fractures, wounds, and dislocations. This medical text demonstrates that the Egyptians had a sophisticated understanding of anatomy and surgery, allowing them to perform procedures that would not be seen again until the Renaissance, thousands of years later. Furthermore, the Egyptians' knowledge of medicine extended to the practice of using herbal remedies, some of which are still in use today. Another civilization that left an indelible mark on modern science is ancient Greece. The Greeks made significant contributions to fields like mathematics, philosophy, and astronomy that still shape the way we understand the world today. One of the most famous Greek mathematicians, Pythagoras, is remembered for his theorem on right-angled triangles. His work laid the foundation for much of modern geometry. But Greek contributions didn't stop there. The mathematician Euclid, often referred to as the father of geometry, compiled and systematized the knowledge of his predecessors into a single volume called The Elements, which remained a primary textbook on geometry for over 2,000 years. The Greeks also advanced our understanding of astronomy. The Greek philosopher and mathematician Aristarchus of Samos was one of the first to propose a heliocentric model of the solar system, suggesting that the Earth revolved around the Sun, rather than the other way around. This theory, though largely ignored in ancient times, would later form the basis for Copernicus's heliocentric theory in the 16th century, which changed the course of modern astronomy. Additionally, the Greeks made significant advances in optics, with philosophers like Euclid and Ptolemy studying the properties of light and the reflection and refraction of rays. These discoveries would become the foundation for later work in the development of telescopes and the understanding of vision. The ancient Chinese civilization, with its long history of scientific and technological innovation, also significantly influenced modern science and technology. From the invention of paper and the compass to the development of advanced metallurgy and agriculture, the Chinese were pioneers in many fields. The Chinese were among the first to develop an understanding of magnetic fields and were using magnets to create compasses as early as the 2nd century BCE, long before they were used in the West. This knowledge of magnetism was crucial for the development of navigation, and the compass remains one of the most important inventions in human history. The Chinese also made significant advances in medicine. Ancient Chinese medicine, with its emphasis on holistic approaches to health, influenced modern practices such as acupuncture and herbal medicine. The Huangdi Neijing, an ancient text on traditional Chinese medicine, contains detailed information on anatomy, diagnostics, and treatment methods that continue to be studied and practiced today. This text also introduced concepts such as the balance of yin and yang, which became integral to Chinese medical philosophy and practices. Another area where ancient knowledge continues to impact modern science is in the field of agriculture. The ancient civilizations of the Americas, including the Mayans and Aztecs, were highly advanced in their agricultural practices. They developed sophisticated irrigation systems, crop rotation methods, and techniques for soil conservation. The Mayans, for example, created terraced fields in the mountainous regions of Central America, allowing them to cultivate crops in areas that would otherwise be inhospitable. These techniques helped to sustain their civilizations for centuries and continue to influence modern agricultural practices in parts of the world that face similar environmental challenges. In addition to the scientific and technological knowledge passed down by these ancient civilizations, there is also the knowledge contained in ancient texts and manuscripts. Many of these texts, such as the Indian Vedas, the Sumerian tablets, and the Greek and Roman writings, contain profound insights into the nature of the universe, the origins of life, and the laws that govern the natural world. Though much of this knowledge was initially disregarded or misunderstood, modern scientists are beginning to recognize the wisdom embedded in these ancient texts. For instance, some of the metaphysical ideas found in the Vedas, such as the nature of consciousness and the interconnectedness of all things, are now being explored by modern physicists in the context of quantum mechanics. The resurgence of interest in ancient knowledge and its potential impact on modern science and technology has led to a number of fascinating discoveries and innovations. Today, researchers are looking to ancient civilizations for inspiration in fields such as sustainable energy, environmental protection, and advanced engineering. The ancient Egyptians' understanding of geometry, the Greeks' contributions to mathematics and astronomy, the Chinese innovations in magnetism and medicine, and the agricultural practices of the Mayans and Aztecs offer valuable lessons for solving some of the most pressing challenges of our time. One example is the growing interest in renewable energy and sustainable practices, where modern scientists are turning to ancient methods of harnessing natural resources. The windmills of ancient Persia, for example, were among the earliest examples of wind energy technology. Today, engineers are looking to these ancient designs for inspiration in developing more efficient wind turbines. Similarly, the use of solar energy in ancient Egypt, where they used solar power to heat water and cook food, is providing insights into modern solar technology and its potential for reducing reliance on fossil fuels. In conclusion, the impact of ancient knowledge on modern science and technology cannot be overstated. The achievements of ancient civilizations in fields such as mathematics, astronomy, engineering, medicine, and agriculture have had a profound influence on the development of modern science and technology. While much of this knowledge was lost or forgotten over time, we are now rediscovering and applying the insights of our ancient ancestors to solve the challenges of the 21st century. As we continue to explore the mysteries of the ancient world, we may find that the key to solving some of today's most pressing problems lies not in new technologies, but in the timeless wisdom of the past. Imagine a world where machines powered by advanced technology were not only built with the precision of modern engineering, but were also capable of performing feats that we, with all our technological advancements, still find difficult to replicate. This was a reality in ancient civilizations, where mysterious and often forgotten technologies flourished for centuries, only to be lost to time. Today, we are still uncovering the remnants of these remarkable machines and tools, which, in some cases, continue to defy explanation. One of the most famous examples of ancient technology is the Antikythera mechanism, discovered off the coast of the Greek island of Antikythera in 1901. This bronze device, believed to have been built around 100 BCE, is often referred to as the world's first analog computer. The mechanism is made up of a complex system of gears and dials, designed to predict astronomical positions and eclipses with remarkable precision. The Antikythera mechanism's gears, which are small and intricate, were crafted with such skill that even modern engineers are still trying to fully understand how such advanced technology was created thousands of years ago. The device was capable of calculating the movement of the sun, moon, and planets, and it may have even been used for navigation, suggesting that ancient civilizations were far more advanced in their understanding of astronomy and mechanics than we once believed. However, the Antikythera mechanism is not the only example of lost ancient technology. Throughout history, civilizations have produced incredible machines, tools, and architectural wonders, many of which were lost to time. In fact, Some of these technologies have only recently been rediscovered, and they continue to astonish experts due to their complexity and innovation. Let's take a look at some of the most fascinating ancient machines and tools and explore what they can teach us about the technological capabilities of our ancestors. In ancient Egypt, the construction of the Great Pyramid of Giza has long been a subject of fascination and debate. While we know that the ancient Egyptians used a combination of ramps, pulleys, and labor to construct the pyramid, the specific tools and techniques they used remain largely a mystery. One theory suggests that the Egyptians may have employed a form of hydraulic engineering, using water to help move massive stone blocks into place. This could explain the precision and speed with which the Egyptians were able to build such a massive structure, even though they lacked the modern machinery that would be needed for such a task today. Another lost technology from ancient Egypt is the Egyptian blue, the world's first synthetic pigment, which dates back to around 2500 BCE. This pigment, made from copper-based compounds, was used to create vibrant blue hues in paintings, ceramics, and jewelry. The creation of Egyptian blue was a highly advanced chemical process that required the precise combination of copper, silica, and alkalis, yet it was mastered by the ancient Egyptians long before modern chemistry came into play. For centuries, the technique for creating Egyptian blue was lost, but researchers in recent years have successfully recreated the pigment, revealing the sophistication of ancient Egyptian knowledge of chemistry. The Romans, known for their engineering marvels, also had a number of technological innovations that we are still uncovering today. One of the most remarkable of these is Roman concrete, which was used to build structures like the Pantheon and the Colosseum. The durability and longevity of Roman concrete are still unmatched by modern materials. Researchers have recently discovered that the secret to Roman concrete's success lies in the use of volcanic ash, which reacts with lime to create a material that grows stronger over time. Modern concrete, on the other hand, tends to weaken and crack after a few decades. This discovery has led engineers to reconsider how we approach concrete construction today, as we search for more sustainable and durable materials. In addition to their concrete, the Romans also developed impressive machines for warfare, transportation, and public works. One such device was the hydraulic scorpion, a type of ancient crossbow that used water pressure to launch projectiles. This device, which operated on the principles of hydraulics, was incredibly advanced for its time, combining mechanical engineering with the power of water to create a weapon of great force and accuracy. The Romans were also pioneers in the use of cranes and pulleys for lifting heavy objects, allowing them to construct massive public works like aqueducts, bridges, and amphitheaters. While many of these technologies were either lost or abandoned after the fall of the Roman Empire, the Middle Ages saw a resurgence of innovation in the form of various mechanical devices. One of the most famous examples from this period is the mechanical clock. The earliest known mechanical clocks were built in Europe during the 13th century, but they were preceded by a number of similar devices from ancient China and the Islamic world. These early clocks used a system of gears, weights, and pulleys to measure the passage of time, and their invention marked the beginning of a new era in timekeeping technology. The mechanical clock would go on to shape the development of modern clocks and watches, and it remains one of the most important inventions in human history. Another fascinating example of ancient lost technology is the concept of lost wax casting, an ancient technique used to create intricate metal objects like jewelry, sculptures, and tools. This technique, which dates back to the ancient Sumerians and Egyptians, involves creating a model of an object out of wax, coating it with a layer of clay or another material, and then heating it until the wax melts away, leaving behind a hollow mold. Molten metal is then poured into the mold to create the final product. Lost wax casting is still used today in the production of jewelry and other fine metal objects, but it's remarkable to think that ancient civilizations were able to perfect this technique thousands of years ago without the modern tools and technology that we have today. In the field of agriculture, ancient civilizations were also highly innovative, developing a variety of tools and techniques that revolutionized farming practices. The ancient Sumerians, for example, developed the plow, a device that revolutionized the way crops were planted and harvested. The plow, which was originally powered by animals like oxen, allowed farmers to break up the soil more efficiently, leading to increased crop yields and the development of more sophisticated agricultural societies. Similarly, the ancient Egyptians developed an early form of irrigation, using a system of canals and water wheels to bring water from the Nile River to their fields, allowing them to grow crops in the arid desert. Despite the ingenuity of these ancient technologies, many of them were lost to time due to the collapse of civilizations, natural disasters, and the shifting of global power dynamics. As a result, modern society often overlooks the contributions of ancient peoples in favor of more recent advancements. However, the rediscovery of lost technologies from the ancient world is increasingly important as we face challenges like climate change, resource depletion, and technological stagnation. By studying the tools and machines of ancient civilizations, we can gain valuable insights into how our ancestors solved problems and applied their knowledge in practical ways. For example, the principles of ancient engineering, such as those used in the construction of the pyramids, can inspire modern architects and engineers to create more sustainable, energy-efficient buildings. Similarly, the rediscovery of ancient agricultural techniques could provide new solutions to the global food crisis, as we look for ways to feed a growing population while minimizing environmental impact. In conclusion, the lost technologies of ancient civilizations offer us a unique opportunity to learn from the past and apply that knowledge to solve the problems of the present. From the advanced engineering of the Egyptians to the mechanical inventions of the Romans, the tools and machines created by ancient cultures continue to inspire and inform modern science and technology. While many of these technologies were lost to time, their rediscovery can provide valuable lessons for building a more sustainable and innovative future. As we continue to explore and understand the remarkable feats of ancient engineering, we may find that the key to unlocking the next phase of technological advancement lies not in futuristic inventions, but in the wisdom of the past. Buried deep beneath the sands of time lie the remnants of once great cities, their foundations forgotten, their stories buried under centuries of dust. These lost cities hold not only the key to understanding the ancient world, but also the potential to reveal secrets that challenge our understanding of human history. As we unearth the remains of these civilizations, we are confronted with remarkable architectural feats, advanced technologies, and cultural practices that suggest ancient societies were far more sophisticated than we ever imagined. One of the most famous ancient cities that has captured the imagination of archaeologists and historians alike is Pompeii, the Roman city frozen in time by the eruption of Mount Vesuvius in 79 AD. The city was buried under a thick layer of volcanic ash and pumice, which preserved its buildings, streets, and even the bodies of its inhabitants. The incredible preservation of Pompeii has allowed researchers to gain insight into the daily lives of the ancient Romans, from their homes and marketplaces to their public baths and frescoes. Pompeii provides a rare glimpse into a society that was thriving and vibrant one moment and destroyed in an instant the next. The fact that we can still see the intricate details of its architecture, artwork, and even the food left behind on tables in its homes shows just how advanced the Romans were in terms of urban planning, technology, and cultural expression. Yet, Pompeii is only one example of many ancient cities that have been uncovered over the years. In Machu Picchu, the Incan city high in the Andes Mountains, archaeologists have uncovered an architectural wonder that was lost to the world for centuries. The city's location, hidden in a remote part of Peru, helped it evade Spanish conquest and subsequent destruction, preserving much of its original structure. What makes Machu Picchu particularly fascinating is the precision with which the Inca engineers built the city. The stones used in its construction fit together so perfectly that even modern tools cannot separate them. The advanced techniques used to build Machu Picchu, along with the city's sophisticated water management systems, suggest that the Inca civilization was far more advanced than previously thought. The city's layout, which aligns with astronomical events like solstices, also hints at a deep connection between the Inca people and their environment, as well as an advanced understanding of timekeeping and celestial observation. As we venture even further back in time, we encounter the remnants of Mesopotamia, often referred to as the cradle of civilization. The ancient city of Babylon, with its legendary hanging gardens and towering ziggurats, stands as a testament to the ingenuity of the Babylonians. The grandeur of the city, as described in historical texts, is awe-inspiring, but much of it was lost over the centuries due to wars, invasions, and the shifting of trade routes. Despite this, recent excavations in Iraq have begun to reveal the city's remarkable achievements, such as its advanced legal system, sophisticated astronomy, and intricate urban planning. The ruins of Babylon provide vital clues about the organization and governance of one of the earliest and most influential civilizations in human history. Furthermore, they challenge the notion that ancient societies were primitive or unsophisticated, showing that early civilizations had a deep understanding of mathematics, law, and social structures. The city of Petra in modern-day Jordan is another ancient wonder that has captured the attention of the world. Known as the Rose City because of its rock-cut architecture and water conduit system, Petra was the capital of the Nabatean kingdom in the 1st century BC. What makes Petra so unique is its integration into the natural landscape. The city's inhabitants carved their homes, temples, and tombs directly into the rock, creating a stunning visual spectacle. The ingenuity behind Petra's water management system, which allowed the city to thrive in an otherwise arid region, speaks to the advanced engineering skills of the Nabateans. Despite being largely forgotten for centuries, Petra is now recognized as one of the most important archaeological sites in the world. It serves as a reminder that even in harsh environments, human ingenuity and adaptability can give rise to thriving, sophisticated cities. One of the most enigmatic lost cities in history is Atlantis, a legendary city described by the ancient Greek philosopher Plato. According to Plato, Atlantis was a powerful and technologically advanced civilization that existed around 9,000 years before his time, only to be swallowed by the ocean in a single day and night of catastrophic flooding. While no definitive evidence of Atlantis has ever been found, the myth persists, and many theories about its location have been proposed. Some suggest that Atlantis was a metaphorical tale, while others believe it could have been a real place, perhaps destroyed by an earthquake, tsunami, or volcanic eruption. Whether Atlantis was a real city or merely a legend, its story continues to captivate our imaginations, raising questions about the potential for ancient societies to possess advanced technologies that could rival or exceed our own. Ancient cities are not only remarkable for their grand architecture and urban planning, but also for the insights they provide into the cultures and societies that built them. The city of Teotihuacan in central Mexico, for example, is one of the largest and most influential cities of the pre-Columbian Americas. At its peak, Teotihuacan was home to perhaps 200,000 people and boasted impressive pyramids, temples, and an intricate street layout. The city's residents were skilled in a variety of fields, including agriculture, ceramics, and metallurgy. Despite being one of the most important cities in ancient Mesoamerica, Teotihuacan remains shrouded in mystery, with little known about the people who built it. Some theories suggest that the city was founded by a multi-ethnic group, while others propose that it was a planned city designed to serve as a cultural and religious center. Similarly, the ancient city of Harappa, part of the Indus Valley civilization in present-day Pakistan and India, was a major urban center that flourished around 2500 BCE. The city was laid out with meticulous planning, including a sophisticated drainage system and well-organized streets. The Harappans had a written script, which remains undeciphered to this day, and their cities were centers of trade and craftsmanship. Despite its size and complexity, Harappa eventually fell into decline, and much of its history remains a mystery. Excavations continue to reveal new information about this lost civilization, but its ultimate fate remains uncertain. The decline of the Indus Valley civilization is just one of many examples of ancient cities that have vanished, leaving behind only their ruins as a testament to their once thriving cultures. As we continue to uncover ancient cities, we begin to realize that these urban centers were far more than just places of residence. They were hubs of trade, commerce, and cultural exchange, and they played a critical role in shaping the course of human history. Many of these cities were centers of learning, where great minds came together to advance knowledge in fields such as mathematics, astronomy, engineering, and philosophy. The ancient Library of Alexandria in Egypt, for example, was one of the largest and most comprehensive libraries of the ancient world, containing countless scrolls and manuscripts that documented the knowledge of past civilizations. Though it was tragically destroyed, the legacy of the library lives on, inspiring generations of scholars and thinkers. The discovery of these lost cities offers a unique opportunity to gain a deeper understanding of our shared human history. While the exact reasons for the collapse or disappearance of these civilizations remain unclear, their remains serve as valuable resources for historians, archaeologists, and scientists. By studying their ruins, we can learn not only about the cities themselves but also about the people who built them, the technologies they used, and the societies they created. The secrets of these ancient cities also challenge our understanding of progress and civilization. If ancient societies were capable of such remarkable achievements, why did they disappear? Was it due to environmental factors, social collapse, or invasion by foreign forces? And, perhaps most importantly, what lessons can we learn from their rise and fall to ensure that we do not repeat the same mistakes? In conclusion, the ancient cities that have survived the ravages of time offer us a glimpse into the ingenuity, creativity, and resilience of our ancestors. Each city holds its own mysteries and secrets, waiting to be uncovered by future generations. Whether we are studying the ruins of Pompeii, the lost city of Atlantis, or the ancient metropolis of Harappa, these cities remind us that human history is far more complex and fascinating than we often realize. They are not just remnants of the past, but living testimonies to the capabilities of ancient civilizations and the enduring legacy they have left behind. The Earth's oceans cover over 70% of its surface, but what lies beneath their vast, dark depths remains one of the most enigmatic and least explored parts of our planet. The deep oceans are a world unlike any other, where light fails to reach, where pressure is crushing, and where life has adapted to the harshest of conditions. The mysteries lurking beneath the ocean's surface are staggering, with many parts of the deep sea still untouched by human eyes. As we venture further into the abyss, we uncover secrets that challenge everything we thought we knew about life, geology, and the very structure of our planet. The deepest part of the world's oceans is the Mariana Trench, located in the Pacific Ocean. This trench, which plunges to a depth of over 36,000 feet, is deeper than Mount Everest is tall. The Mariana Trench is so deep that if Mount Everest were placed at the bottom, its peak would still be over a mile underwater. The trench is home to some of the most extreme environments on Earth. With pressures more than 1,000 times the atmospheric pressure at sea level, the conditions in this part of the ocean are truly inhospitable by most standards. Yet, despite the overwhelming pressure and near-freezing temperatures, life thrives in this alien world. Deep-sea creatures, such as giant squids, bioluminescent jellyfish, and the elusive anglerfish, have evolved to survive in this dark, crushing abyss. These creatures rely on unique adaptations, like bioluminescence or specialized proteins, that allow them to live and hunt in the extreme conditions of the deep ocean. Despite the presence of life in these depths, much of the Mariana Trench remains a mystery. The trench has been explored only a handful of times, with only a few individuals, such as film director James Cameron, having made the perilous journey to its deepest point. Even with modern technology, the challenge of exploring the deep ocean is formidable. The immense pressures, freezing temperatures, and lack of light make it a harsh and unforgiving environment for any exploratory mission. Yet, each dive into these deep, unexplored regions has yielded astonishing discoveries. For example, the discovery of extremophiles, organisms that thrive in conditions once thought to be uninhabitable, has revolutionized our understanding of life on Earth. These organisms are capable of surviving in hydrothermal vent ecosystems, where volcanic activity heats the water to temperatures that would otherwise be lethal to most life forms. The discovery of such creatures suggests that life on Earth, and perhaps even life elsewhere in the universe, can exist in environments far more extreme than we previously imagined. One of the most significant mysteries of the deep ocean is the existence of hydrothermal vents, fissures on the ocean floor that emit hot, mineral-rich water. These vents support complex ecosystems that rely on chemosynthesis rather than photosynthesis. At these depths, sunlight doesn't penetrate, making photosynthesis impossible. Instead, the organisms living near hydrothermal vents rely on the chemical energy emitted by the Earth's mantle. At these vents, life exists in the form of tube worms, clams, and shrimp that feed on sulfur bacteria, creating an entire ecosystem in the absence of sunlight. The discovery of these ecosystems has radically shifted our understanding of life's potential to survive. These findings suggest that life may be possible in places like the icy moons of Jupiter and Saturn, where liquid water and chemical energy might exist beneath the surface, sheltered from the harsh environments of space. In addition to these fascinating biological discoveries, the deep oceans hold other mysteries, including shipwrecks, sunken cities, and geological features that may be older than humanity itself. One such example is the Bermuda Triangle, an area of the Atlantic Ocean known for its reputation as a site of unexplained disappearances of ships and aircraft. Over the years, numerous theories have been proposed to explain the phenomenon, ranging from magnetic anomalies and methane hydrates to more fantastical explanations, including extraterrestrial activity. While no definitive answers have been found, the Bermuda Triangle remains one of the most intriguing mysteries in the ocean's depths. Another significant mystery is the Yonaguni Monument, an underwater structure found off the coast of Japan. The monument consists of a series of large, flat terraces and sharp edges, leading some to speculate that it could be the remnants of a man-made structure or even an ancient city that sank beneath the waves thousands of years ago. Despite extensive research, there is still no consensus on whether the Yonaguni Monument is a natural formation or the work of ancient civilizations. Theories vary, with some suggesting it is an archaeological site, while others argue that the formation is purely geological. Regardless of its origin, the Yonaguni Monument adds to the growing list of underwater structures and artifacts that hint at a deeper connection between the oceans and ancient civilizations. The Black Sea also holds its share of secrets, including the remarkable discovery of ancient shipwrecks. In 2018, an expedition discovered a well-preserved shipwreck from the ancient Greek period, dating back to over 2,400 years ago. The ship, found in waters over a mile deep, was remarkably intact due to the unique anoxic, oxygen-free conditions of the Black Sea, which prevent decay. The discovery not only sheds light on ancient maritime technology, but also suggests that the deep oceans may hold many more artifacts from ancient civilizations that have long since disappeared from the historical record. The preservation of these artifacts challenges the traditional narrative of history, offering new insights into trade, travel, and the interconnectedness of ancient societies. One of the most fascinating aspects of deep ocean exploration is the discovery of underwater caves. These submerged caves, some of which are only accessible via specialized diving equipment, contain fossils, ancient tools, and even human remains that date back tens of thousands of years. For example, in the cenotes of Mexico, which are natural sinkholes that have flooded over the centuries, divers have uncovered evidence of ancient human habitation, including tools, pottery, and skeletal remains. These findings have revealed that early humans were able to adapt to and thrive in harsh environments, using the resources provided by the ocean to survive. The caves also contain ancient cave paintings and carvings, offering a glimpse into the beliefs and culture of our ancestors. The deep oceans also serve as a natural archive for our planet's history. Oceanic sediments act as a time capsule, recording the events and changes that have shaped the Earth's climate and ecosystems over millions of years. Scientists use sediment cores extracted from the ocean floor to study past climate events, such as ice ages and periods of intense global warming. By analyzing these cores, researchers can reconstruct past environments and better understand how the Earth's climate has fluctuated over time. This information is crucial for predicting future climate trends and understanding the natural cycles that govern our planet's climate system. As we continue to explore the deep oceans, new technologies are allowing us to explore previously inaccessible areas. Autonomous underwater vehicles, AUVs, and remotely operated vehicles, ROVs, are revolutionizing our ability to map and explore the ocean's depths. These cutting-edge technologies allow scientists to gather detailed data from areas that were once unreachable due to the extreme conditions of the deep ocean. With the help of AUVs and ROVs, researchers are making new discoveries almost daily, from new species of fish and invertebrates to the remains of ancient ships and long-lost cities. The mysteries of the deep oceans extend beyond the biological and geological, reaching into the realms of science fiction and the unknown. For centuries, stories of sea monsters, such as the Kraken and the Loch Ness Monster, have captivated our imaginations. While most of these tales are steeped in myth and legend, the idea that the oceans may harbor creatures beyond our comprehension persists. In recent years, there have been reports of strange, unidentified creatures captured on deep-sea cameras, sparking speculation about undiscovered species that could inhabit the ocean's deepest trenches. Whether these creatures are simply unknown species or something far stranger, they continue to fuel the mystery of the deep. The question remains, what other secrets does the deep ocean hold? As technology advances and our understanding of the oceans improves, it is likely that we will uncover more astonishing discoveries in the coming years. Whether it's the discovery of new life forms, ancient artifacts, or hidden cities, the deep ocean promises to continue to reveal its secrets, one dive at a time. For now, the deep oceans remain one of the final frontiers of exploration on Earth, holding the mysteries of our planet's past and future within their depths.